This question came in 2014 for 2 marks in set 2 for EC gate. The question states, assume electron charge, standard value 1.6 times 10 power minus 19 coulomb, and Kt by Q, which is thermal voltage, is given 25 millivolts, and electron mobility is given mu n 1000 centimeter square per volt second. If the concentration gradient of electrons injected into a p-type silicon sample is this. Okay, so the carrier concentration gradient of electrons. So make a note of electrons. So what is carrier concentration gradient? Del, because they are talking about electrons, del n by del x, which is concentration gradient of electrons in the p-type silicon sample is, this is equal to 1 times 10 power 21 per centimeter power 4. Now let's just check the units. N is always number per centimeter cube and x is centimeters. It makes sense. Number per centimeter power 4. Now the question is the magnitude of electron diffusion current density in ampere per centimeter square. Now what is diffusion current density? We are talking about electrons injected, so there will be concentration gradient of electrons. Hence we calculate only for Jn. Okay, of course they are asking electron diffusion current. So Jn diffusion is given by Q dn del n by del x. So Q, we know what it is, 1.6 times 10 power minus 19, okay, times dn. Okay, the diffusion constant for electrons is not given, but we know Einstein's relationship here. dn is kT over q times mu n, which is 25 millivolts times mu n is 1000 centimeter square per volt second. Now we can write this as 25 centimeter square per volt second. We'll substitute it here. 25 centimeter square per volt second, this is coulomb, times 1 times 10 power 21 per centimeter per 4. It becomes square. Coulomb per second is basically the amperes, so we'll write there. Okay, and of course, by the way, we had here volt gets cancelled because there is a volt here. Okay, so there is no volts here, so coulomb per second is ampere. Now this equation I am writing here, 1.6 times 25. Now the powers, if you see 19 and 21, so it becomes 10 power 2. Now we are left with amperes per centimeter square. So let me reduce this and find. So 1.6 times 25, 40, and 10 power 2 is 100, 4000 amperes per centimeter square. So the answer is 4000.